So I want to start with a little bit of backstory on a monolith to microservices initiative that I was involved with in 2014 and 2015 called Project Mario. The project was an Australian headquartered but global ASX listed company. And it's a great story because whilst we didn't know it back then, it had all the ingredients for success that are now backed up by numerous industry research and modern tooling. Before we started Project Mario, the application boundary we're talking about was actually managed by a separate team, and their simplified build pipeline looked a bit like this. The challenge was, though, that the integration testing pipeline was pretty much always red. Conveniently, just prior to a release being scheduled, it would briefly light up being green, and then it would regress afterwards. And it was really the sole focus of one or more people to get it green, usually days or weeks worth of effort before a release could be completed. And I'd go on to learn later on in my career that this was a really common thing in the industry, but I digress. There was the usual paperwork, process theatre and rubber stamping, change approval boards or CAB that needed to be completed to get the change released. And the few team members that were unluckily drew the short straw were also due to support the pre, during and post-release activities, which was also, a non-trivial task. The result was that, as a general guide, releases only happened every couple of months. Sometimes they were more frequent, but team velocity took a serious hit and large amounts of caffeine and team collaboration were required to get it through. But for the most time, it was okay. This was a reality in which we lived, and many people have accepted this fate. We really just avoided deployments because of the overhead and only doing them as frequently as needed every couple of months. But by the end of the project, in just a few short months, the result was that a commit could be shipped to production and be in the hands of a customer in just 7 minutes. And this metric is now known as change lead time, and we'll talk a bit more about that later. But the ability to release this quickly and safely, I believe, changed the way this company delivered software forever. And because feedback loops were shortened, engineering teams were able to work closer with product teams on smaller changes and iterate based on analytics, usage data, business impact, and so on. Projects could be course corrected quickly and cheaply instead of being planned 3 or 6 months in advance. And teams were really energized by this. And I recall a session where we sat down with the managing director and took him through the outcomes of this initiative. And we actually got him to sit down with an engineer on the team to make a minor change to the content on the webpage. And he was just genuinely baffled about what we just demonstrated to him when a few minutes later, it was showing up in production. And I think the words that he used are something to the effect of, "This is what every team needs to be able to do. How can we do that?" And this really set the company on a course towards some great achievements, and also for my own personal journey. So we're going to revisit this story throughout the webinar, but before we move on, let's just talk about what we've got planned for this session. We're going to talk about the challenge in moving to a modern microservices architecture. We're going to look at 4 evidence-based metrics that you can use to measure and drive positive change. We're going to look at the problems in how we test and release distributed systems today. We're going to then look at maybe how we can build an alternative testing investment portfolio and revisit the ingredients for success that we've discovered in this project. And ultimately, I want to be arming you with some of the most important strategic decisions we made that are now backed up by years of research. So the technology landscape is moving at an ever-increasing rate. The trends like cloud, serverless, the rise in inaccessibility of AI and machine learning as a viable technology, and of course IoT and edge computing is really changing things. And this is leading to democratization of data within organizations and without them, outside of them. There's a demand for faster and more scalable and more complex user-friendly products and services, and there's a huge shift in our architectures because of this. So architectural patterns like microservices are still evolving. In the early days of RESTful services, things looked a bit more like this, where teams had separate bounded contexts such as orders or identity, and teams could work autonomously within those bounded contexts. Perhaps they manually scaled the services, manually managed those services using auto scaling and smaller components. But mostly they were synchronous invocations, and we still ran a lot of servers. But microservices are evolving, and let's say we zoom into that orders domain. There are several microservices starting to be exposed, and beneath that tip of the iceberg, this is where we're seeing the real shifts. We're seeing this microservices or API layer at the top, but beneath that now we're seeing polyglot persistence to serve various business functions, and more event-driven and CQRS type architectures. So for example, here's a hypothetical architecture for that order microservice. And there's many benefits for these kinds of architectures. The asynchronous and event-driven nature really makes them robust to many forms of failures. They're extremely scalable, and when coupled with cloud computing and serverless, can be really cost-effective. They can be connected to external data sources or other APIs to democratize data across an organization, which adds value to customers throughout a journey and providing deeper insights for organizations themselves. So for example, in the order context, we may want to have a view of the customer locally to serve better recommendations during the checkout process. And with cloud providers like Amazon, you can do this kind of thing really quickly. In fact, that exact architecture is something I put together in a day as a proof of concept. But these architectures are complicated. For example, here is one of our customers' architectures as seen by Pactflow. And they leverage many of these patterns. And as a global retailer, they are very sensitive to market and consumer pressures. So it's not enough just to have the latest technology and the modern architectures. We need to be able to continually evolve our product in the market, and that requires rapid iteration and feedback cycles. So as alluded to in Lewis Carroll's famous book, the competition isn't standing still. You need to continually evolve at a faster pace than your competition. But traditionally, we've had to trade off the pace of change against the stability of a service. But the science behind this is starting to mature, and we now have a much better picture of what good looks like. So the long-running State of DevOps report has identified 4 key indicators of high-performing organizations, where high-performing means success in the market, amongst other things. And for 6 years straight, their research has consistently shown that speed and stability are actually outcomes that enable each other. So the first 2 key metrics are about throughput, and the other 2 are about stability. So let's have a look at those in turn. The first 2 are lead time for changes and the ability to deploy on demand. So lead time is how long it takes to make a commit and get it to production, and the ability to deploy on demand is as you think. And high-performing organizations are 100 times faster from commit to deploy and do 200 times more deployments. On the stability side, we measure change failure rates, so how often a change results in a production issue, and how fast you can restore a service, or mean time to recovery. And again, high-performing organizations fail 7 times less, and when they do fail, they can restore literally thousands of times faster. Automated deployments are also associated with about 70% of these elite performers. So deploying and recovering quickly is really what gives the company the agility that I was talking about earlier. Back on the metrics, these metrics measure outcomes, but they're not necessarily actionable. So you might want to consider measuring lower level metrics at the team or project level to find out what's blocking those top line metrics. Things like build duration, feature cycle times, the number of issues caught throughout the process, how much time you spend doing certain things, and qualitative measures such as job satisfaction and burnout. So the question becomes, well, what should we be doing to influence those metrics? Well, to contextualize them, this is actually the broader model that DORA have uncovered in their research, showing the constructs that contribute to or inhibit organizational performance. We're not going to go through this in detail now, but note that the highlight area is the scope of an impact of microservices and cloud adoption as it improves your performance. And as you can see, it's not a very large area it's covering. Microservices themselves just don't cover a lot of the other critical predictors of success, which is the take-home point here. So how can we both move fast and scale and deploy more sophisticated technology and architectures and our teams than before? Well, being able to deliver fastly and safely is going to highly depend on the performance of the factory that releases that software to production. And a key part of that factory is the release pipeline. As an industry, we're pretty good at getting the build and test part right. Practices such as TDD and CI have been around for a long time now, and most organizations are doing okay there, including even deploying to production. It's usually the integration testing process and the release coordination that is actually the roadblock to most companies. So coming back to those numbers, only 20% of companies are in that elite performer category. So there are many reasons why other organizations won't reach that target. But one of the biggest barriers is their test and release pipelines, as well as the supporting processes for those. So things like managing test data, managing the test environments, fixing test environments, maintaining those test environments is a huge part of their time. So let's briefly talk about how we test and release microservices now. So given this fictional architecture here, what you would normally do, we would use what's called end-to-end integration testing, where we drive requests through the system from the outside, and real requests have to pass all the way through the system. So it needs to go through the website, down through API gateways, and back out. And you might use tools like Postman for APIs or whatever user interface testing tool you use. And this is great. It gives you confidence. But the downside is they're slow. In fact, there's a bunch of problems. But the first one is that they're slow. They need to talk to real systems. They need to send out real emails or do whatever it is that the product does. And often that is not a quick thing. And often you need to run them in parallel, in serial. You can't run these in parallel because they depend on previous state having been created or generated as part of the process. Also, you need to manage test data. And this can be really challenging, managing those test environments. You now need to coordinate across multiple teams to get the right versions of the right software configured correctly with the right test data, with the right set of tests for these kinds of things to work. And if any one of those things are out of sync with each other, well, then you risk having a flaky test or a build failure, which has nothing to do with the actual system not being correct, but has everything to do with configuration and coordination. So it's quite challenging. And that's what makes them quite fragile. They're also hard to debug when something does go wrong. You need to then go into tools like Splunk or whatever your log tool is to look at aggregated logging to find the correlation ID, to trace the request through the system, find out which part of the system failed, find the right version of the code, even if it's not in your code base, and then dig through that to find what went wrong. And that can also be very time consuming when there is failures. And again, a lot of the time, those failures aren't actually related to a real functional problem, but simply a symptom of the setup. It's very difficult to get coverage this way as well. So because of the number of permutations of what each of those systems can do, the more systems each test needs to traverse, the more tests you need to do to get good coverage. So each system that you need to pass through squares the number of tests you'd need to do to get full coverage. So in most applications, at a minimum, you're already going to be in the millions of tests just to get 100% coverage if that's what you're trying to do. So most companies obviously won't do that, and they won't get good coverage. But that's not really what they're intended to do. And lastly, because you need to test everything together, that now means you need to deploy everything together. And that causes a bunch of issues. And the main issue is that doing that is if one component fails, they all need to be rolled back. This causes all kinds of issues with the business, as you can imagine. But technically, now you've got teams waiting on each other to get things done. And that results in all kinds of wait and queues. And as we know from lean theory, that's not a good thing. But also just context switching for the developers. They're going to lose time in that context switch. So what we find is that our teams were able to build independently with our microservices. The code is set up that way, but they're forced to collaborate closely in order to ship the code. What we really wanted was cohesive services that are loosely coupled, but we actually have cohesive teams that are tightly coupled by those services. And this coupling results in a non-linear impact on critical release activities. So for example, as we add more teams or components into the mix, we find that the time spent managing environments or the number of environments we need goes up exponentially. Or we have to time share those environments, in which case we have to coordinate them, and that creates build queues. Our build times start to go up as well, because now each team that comes into the mix, all of a sudden we're incurring their integration testing suite cost, even though we didn't do anything new. On top of that, the risk associated with the change starts to go up, and that usually results in production issues. And the standard result to that, or response to that, is someone will create a separate integration testing team whose job is to make sure everything works together. And the impact of that is that now you've got more gaps between code being created and code being shipped, which results in developer idle time and essentially waste in the system. So the approach that we took from monoliths just does not work for highly distributed systems. So we've got a better appreciation of the problem and the metrics that we can use to start to measure and navigate that problem. What can we actually do about it? Well, returning to our story, whilst the research was still emerging at the time, we knew that a shift to the cloud, a cross-functional collaboration and code ownership was leading to success in the industry. So the DevOps movement was taking off. And we also just felt the pain around the release process. And this led to those top-line goals of the initiative around addressing culture, moving our code to the cloud, and getting ourselves into that microservice autonomous working place. But what we did that really transformed things for us was we measured what we did and we looked really critically at our processes. And the cornerstone of that review was what we called an activity accounting, which revealed a lot about how we spend or actually spent our time day to day versus what we thought we spent. And it turned out that a lot of the things we worked on weren't value creating activities. So whilst the goal of 100% value creation is never going to be possible, nor something you actually want, we expected it to be a greater part of our day to day. And unfortunately, that was a rude awakening. Now, those numbers are just an example, but it's worth repeating that we didn't see numbers that were positive in that sort of value creation time spent. So the first thing we realized through this activity was that being able to deploy faster or recover quicker was actually more beneficial than having the 100% coverage. Because what we saw was we had a long and extensive end-to-end integration testing suite, but we didn't catch all the problems anyway. So when there was a problem, we either had to skip those tests during a cab emergency approval to try and repair things quickly, which obviously can result in other problems, or B, we wore the cost of a long time to recovery. So really what we discovered was the benefits of optimizing for mean time to recovery. So what we did was we created a deployment pipeline budget of 15 minutes, which turned out to be quite genius because it meant that we had to make really hard choices about what we included in line to our release pipeline and to be able to innovate on approaches to keep that down. And that almost immediately ruled out the significant use of any end-to-end integration tests because they simply took too long to run. Independently of this, we realized that our end-to-end suites weren't just painful, but they were actively working against us. We just weren't getting confidence from them anyway. And they were too slow, and we spent too much time on them, proportionate to the value creating activities. So we had two actions there. Delete all the tests and start again, or at least look at the ones that we only needed that we thought were necessary. And we also investigated a new form of testing called contract testing. The next thing we noticed was that there was a lot of overlap between our forms of testing, and this was just resulting in, extra work that we didn't need to do. And so the action there was just deleting tests that we didn't need and rebalance the tests where the gaps existed. And finally, we realized that the change approval board, or the CAB, was not really serving us. We were just serving it. And what we did was we showed that smaller changes were actually safer. And unfortunately, we had to do this by sort of making it painful for the cab to operate with so many small changes and really showing them what good looked like. But, in a trustworthy way, we really built that trust with them, and we showed leadership in what we could be doing differently to get to where we want to get to, which ultimately is a safe and reliable production environment. So let's focus in on the actions related to testing. So a brief primer on the test pyramid, and for those who haven't heard of it before, is a heuristic to help you work out essentially your allocation of time and effort on various types of testing, first proposed by Mike Cohn. As you move up the pyramid, you get more confidence, but at the expense of slow and costly feedback. And just like the food pyramid, really what you want to be doing is spending more time at the bottom and less at the top. And what we realized is we'd really overinvested in the end-to-end tests, and we were feeling the pain because of this. So the first action was just to rebalance that. We removed as many of the end-to-end tests as we could, and we spent more time adding a balance of functional tests back in. So what we noticed was those end-to-end tests were doing a lot of the provider functional testing, something that didn't really belong in the consumer code base. So we moved those out. And we also added a whole bunch of new types of tests called contract tests into the mix. And that really slimmed down the need for end-to-end tests as well. So just diving into contract testing for a moment, because this really was the cornerstone of this new testing strategy. Contract tests allow us to check that messages sent and received between systems are correct by capturing the needs of those interactions in what's called a contract and making those interactions and the scenarios between them explicit. So the conversations essentially between those components were made very explicit. And what we can do at testing time is guarantee that those conversations could be met in real life. So for example, can the website send the correct message to the API, and will the API send the appropriate response? So on this diagram, and pretty much any architectural diagram, Anywhere there's an arrow between two systems, you have a contract, whether explicit or not. And so contract tests aim to ensure that those integration points are compatible and help them evolve safely over time. And now traditionally these things are covered as part of end-to-end tests. But pack tests are a bit different. Pack tests only focus on a single integration point at a time. And so you're focusing, let's say you're talking about a website. You're running your test for the website, you just care about the website. Or if you're testing an API, you just test your API. You don't have to take it all together. And there's many benefits of this approach. The first one is that you only need to focus on a single integration point at a time. So it's a lot less complex to even think about. But you don't need to deploy them. So you get this feedback locally on your machine, and that feedback is very, very quick. But also when it does fail, because it's running locally and there's no other systems involved, debugging the issue is a lot easier. It's always in the box you're testing, so the website or the back end, whatever it is you're testing. And that makes it very easy to debug. There's no need to deploy them, so the feedback loops are much, much faster. And because of this, the test will actually scale linearly because it doesn't need to depend on other systems being there to run that test. But ultimately, it enables us to deploy things independently. Because we're only testing things separately, we don't now need to have this problem where we need to deploy it all together because we don't have the confidence that without testing it together, they're not going to work. We're always testing things in isolation, so we can release in isolation too. It really removed the need as well for a complex coordination around the releases because we had static information that told us which components were compatible with each other at build time. So this gave us a good plan of attack. Looking at our testing pyramid and our test allocations, we reviewed a bunch of things. But what we really found was that end-to-end integration tests we use as a catch-all for all types of integration testing and acceptance testing and functional testing. And by separating the integration testing from the other forms of testing, we really relieved end-to-end tests of most of their duties. So what we did was we pushed up the line of expensive tests in the pyramid, and because of that, rebalancing, we saved a lot of time and money doing so. The second thing we did was we shrunk the pyramid. As I said before, we didn't need as many tests. So just simply shrinking that pyramid just meant we weren't maintaining as many tests. And deleting code can be difficult, but every code, including tests that you need to maintain, is something you need to maintain over time, and that cost adds up. So we decided it would be better to put some of the testing outside of the pyramid. So the test pyramid has a lot of weaknesses, as useful as it is, and a more holistic view is actually needed. So whilst outside the scope of this presentation, we recognize that it only helps us with the path to production, not necessarily what happens once we're in there. So an investment in our post-deployment quality approach was also required. Production testing and monitoring was needed to ensure that we could indeed reduce our mean time to recovery and create those engineering feedback loops to address the root causes, something that can be much more difficult to do when there's not that cross-functional team and associated organizational alignment. And in our project, we eventually removed the end-to-end test altogether in favor of these forms of testing. So continuous testing doesn't also suffer from the issues of end-to-end tests because they run continually and they may page you if they fail. So they're less likely to be flaky. They don't slow a release down and they don't require complex coordination amongst teams. So they're a really low maintenance version of those end-to-end tests. And for example, what we did there was you might check a login or check that you can do a sign up, some of those key business transactions. They were the kinds of tests we ran continuously in production to make sure the system was working. Okay, so let's talk about what was the impact of these changes. Starting with contract testing, one benefit you get is API documentation. There's up-to-date and updated architectures for free. Because the contracts are static, you can generate these kinds of artifacts. And as shown earlier, here's an actual customer's architecture as viewed by the contract information in Pactflow. The architecture has about 155 applications, 258 integrations, and despite this complexity, teams are able to deploy with confidence multiple times a day. So one of the lead engineers said this about their contract testing. With the confidence and safety net that contract testing provided, the team consistently achieved between 10 and 20 production deployments a day. And this, coupled with the ability to segment work into technical areas due to microservice architecture, meant that the delivery remained consistently good even as the product scaled to over 150 microservices. And he went on to say something interesting. This approach allowed us to create a benchmark whereby on the first day, an engineer would be able to take a simple story, understand the existing architecture, and deploy that task to production by lunchtime. And if this wasn't achieved, we knew that our process had slipped, and we needed to focus on improving it. Another recent case study is Treatwell, the largest hair and beauty product website, bookings website in Europe. And they've recognized the benefits of those 4 key metrics as well, and set the goal of delivering smaller, more frequent releases of independently deployable applications. So from a few years ago, they went from a few releases a month to an average of 45 a week now. And if you can sort of see that chart of participants over time, which is an application, you can see that deployments actually sped up over time and the lead time stayed flat. So as you can see, speed and stability are just not in conflict. Okay, what about Project Mario? Well, as we talked about earlier, we went from a lead time of what was really a couple of months to 7 minutes. They could commit a change, and within 7 minutes it was in front of a customer. It was completely hands-off. They did multiple deployments a day, and it was a virtually cost-free release process. And this pattern other teams took and followed both culturally and technically and emulated throughout the organization. And I believe this truly did transform their culture. But when you overlap the ingredients we talked about on the model we talked about earlier, there's no wonder this project was so successful, because almost all the core constructs were addressed directly in this project. The cloud-based microservices architecture gave us a better properties in terms of code maintainability and a loosely coupled architecture. The pipeline was a true continuous deployment pipeline, addressing CI, deployment automation, and those continuous delivery constructs. Our test approach was fully automated and extremely fast, and that addressed our continuous monitoring in production, as well as our automated pre-release quality gates. And lastly, the effort around cultural transformation. We work with a change approval board, or CAB, to show them that small and frequent changes were both safer and easier to manage, and really work with them to change that process. And one last call I'll make here is around culture of psychological safety. We didn't change that in the project. That's something this company had from the beginning. For example, when you join the company as an engineer, during your induction, you're told that you're part of a team, a great team who hired you because they trust you, they believe in you, and they're going to back you to make that difference. And they generally did back that up by giving you the keys to production. So you could change production and have that autonomy to do so. So when we told our tester that we're going to delete his integration testing suite, or our operations person that we're going to stand up the production stack as a developer, we had the trust and support behind us to execute on that bold plan. Of course, it still took bravery on the part of those individuals, but without that cultural support, I believe many of those technical achievements just wouldn't have been possible. So let's recap. We talked about the challenge in moving to a microservices architecture. The architectures are evolving rapidly, but the microservice movement alone won't correlate strongly with success. You really need to combine that with process and cultural change to amplify those benefits. The second thing we learned about was those 4 key metrics from Dora, as well as the report, and you can use those to drive positive change. And those metrics are lead time, so how long it takes to get a release out the door, and deployment frequency, and the stability, so how often do you have production failures, and how quickly can you recover from that. And we learned that stability and time to market really enable one another. They work together. We talked about the problem with how we test and release distributed systems, and particularly the issue with end-to-end integration tests, how they're both economically unstable and practically difficult, and how optimizing for mean time to recovery is actually probably a better strategy for most companies. And we talked about an alternative investment portfolio for your testing and how you can reshape that pyramid to be more economical with that approach.